All right, so we're going to be multiplying binomials. A binomial is nothing more than a group of two terms. So a term is something that's separated by plus signs or minus signs. So here we can see one term, one term, two term. So in these parentheses are two binomials. Now we could multiply any amount of terms, polynomials, but for us today, we're going to be multiplying by binomials. And the way we do this is we distribute. So we want to make sure that each term gets multiplied by the other. So if I want to multiply this, I multiply this x by x minus 2, and I multiply this 5 by x minus 2. So I break this down as x times x minus 2 plus 5 times x minus 2. And so what I now do is I distribute. And distributing one term is a lot easier than distributing two terms. So I get x squared minus 2x plus 5x minus 10. Now in the middle here, I can see that I have a negative 2x and a 5x. So what I do is I actually combine them by adding. So 5x plus negative 2x is 3x. And so once all terms are combined, I have a beautiful product of these two binomials. So here you should be able to try these on your own. So if you want to, you can pause the video here and try them out yourself. And I'm actually going to go through them right now. So hopefully you paused and you gave these a shot. But here, what I'm going to do is I'm going to multiply this whole second binomial by the b and then by a minus 3. So I'm going to have b times 8b plus 1. Don't know why I drew that. b plus 1. And then a minus 3 times 8b plus 1. So 8b squared plus b minus 24b plus a negative 3. So if I combine these here, this is going to be 8b squared minus 23b, and plus a negative is just minus 3. So that's my final answer. Over here, again, if I take this 6k plus 2 and multiply it by 2k and a 7, I get 2k times 6k plus 2 plus 7 times 6k plus 2. Distribute this in, I get 12k squared plus 4k plus 42k plus 14. Here I can combine these like terms, so I get 12k squared plus 46k plus 14, and that is my final answer, all multiplied out and happy. Now there are a couple of special cases. You can multiply binomials like this, but there are some shortcuts in special cases. The first one is a binomial squared. Now what some people think is you can distribute this in, and this becomes x squared plus 25. That's actually not the case. You can't do that with exponents and terms, so plus signs. So these are like lava pits. Squares cannot cancel or cannot cross over these pits of lava, plus signs and minus signs. So watch out for that. If I were to multiply this out, don't forget this is x plus 5 times x plus 5. So if I multiply this, this becomes x times x plus 5 plus 5 times x plus 5. So I get x squared plus 5x plus 5x plus 25. Combine the like terms. And look, there's a 10x that's right there in the middle that if you just distribute this in, you would miss and you would be wrong. So be mindful of that. But there is a shortcut. And the shortcut is actually this. It's if you square the first term, so x squared, and you square the last term, so 5 squared, which is 25, and then you add, actually let me write that out as 5 squared. And then for the middle term, it's always going to be 2 times these two terms multiplied. So x times 5. So I get x squared. 2 times 5 times x is 10x. plus 25. This is very helpful. And so, if I give you something like x plus 3, maybe right now you can multiply that out in your head. And you don't need to go through all of these steps. Think about yourself working on a test. And if you have ever run out of time on a test before, if you can use little tricks like this to make sure you get through the problems more quickly, then you'll have more time to work on the more difficult problems. The general form looks like this. If I have a plus b squared, that's going to equal a squared plus, a squared plus 2 times a times b plus b squared. And that actually gives us a perfect square trinomial, because this has 3 terms, whereas we started off with a binomial squared. This has 3 terms, so it's a perfect square trinomial. And then lastly, we also have a product of a sum and a difference. These are called conjugates. You don't need to know this word right now. It does help you out later on in algebra courses, but for right now, just call it sum and a difference. I'm going to multiply this out the old-fashioned way. So again, x times x minus 5 plus 5 times x minus 5. It gives you x squared minus 5x plus 5x minus 25. Well, if I combine these middle terms, look at what happens here. Negative 5x plus 5x is 0. So I actually get x squared minus 25. Here, there's a shortcut. Whenever we see that the first term is the same, so x and x, and the second terms are opposites, meaning the sign has switched, what we can do is we can square the first and subtract the square of the second. So x squared minus 5 squared, just x squared minus 25. That's it. This is called a difference of 2 squares. Generally, what this looks like is if I have a plus b times a minus b, this multiplies to a squared minus b squared. And that's it. So again, you can see that this is really simple here. And you will have problems like this, and I definitely will put some like this on quizzes and tests. So watch out for it. It's a lot easier to do this than to work out and write out every little tedious step. And same thing with the binomial squared. But if you don't like them, if you just can't make sense of it, that's fine. Work on multiplying binomials, and you really can't go wrong.